This is our first video on our new unit about logarithmic functions. This video title is Introduction to Logarithms. We're going to talk about what a log is, how we use it, how we can apply it to certain situations to solve for things that we thought were probably impossible. So we're wanting to figure out what the x's are in each of these two examples. 2 to the x power equals 8 and 2 to the x power equals 10. Now I know that 2 to the third power does equal 8, so the first problem is rather easy to figure out. So my x is actually equal to a 3. But in my second example, it can't be a 3 because that's an 8, and it can't be a 4 because that's 16. So my x is neither 3 or 4 because I'm trying to figure out 2 to the what power equals 10. So apparently it's 3 point something something something. But what is that something? How do we get that answer? Well, in the past we would say that we really didn't have a good way or know of a good way to do this. That's what this unit's all about. Logarithms help you figure out what x's are when the x is an exponent and the answer isn't easily reasoned out. So what is a logarithm? We usually abbreviate this as log. So I'm going to start calling them logs instead. Logs are the inverse to an exponential function. We've been working with exponential functions such as b to the x power equals y. We can rewrite this as log base b of y equals x. Basically, what we do is the x is going to go to the opposite side and the y is going to come this side. The b, which is the base, ends up down in the lower section. So looking at the way that I drew these arrows, you see that what we're really doing is switching x and y around, which is what we do with inverses. So how do you write a log? You take the base that has an exponent on it, such as the b, and it's written nice and small, lower than everything else. It's lower and smaller than the log, the y, the equal sign, and the x. The exponent is now what the problem equals. And the y is what the problem in the beginning was equal to. It's on the other side of the equal sign. So it's on the other side of the equal sign. How do you correctly read out loud what this log little 2 and 8 says? Is we say log base 2 of 8. If I were to write down this, I would say log base 3 of x. It's important that we are clear in our vocabulary and our speaking so that we communicate exactly what we mean when we're talking in our mathematical language. Let's do a quick little practice on changing logs in the exponential form and exponential form equations back in the log form. I see in my first example that the base is a 3, so I write that nice and big. Remember that logs actually equal their exponents, so the 2 is actually the exponent. It equals the 9. This is definitely a true statement. 3 squared equals 9. That's how I know I did it correctly. Now let's write the exponential form back in the log form. What is the base in my problem? It's an 8, so I write that as a small 8 lower than the log. My of is on the other side of the equal sign. It's a 1. Log base 8 of 1. And it will equal whatever the exponent was, which is 0. Pause the video, try these two, then unpause it and check your answers. Okay, I hope you got these answers. If you didn't, remember that the base goes down low. Remember that the base goes down low and logs equal the exponent, so the exponents end up on the other side of the equation when you write a log. Sometimes logs are very easy to calculate. Log base 3 of 81 is asking us 3 to the what equals 81. Well, that answer would be 4. 3 to the 4th power equals 81. Log base 4 of 64 is asking us 4 to the what power equals 64. That is equal to 3. And log base 5 of 1 is asking us 5 to the what power equals 1. Well, only a 0 exponent will give you an answer of 1. There are a couple of special circumstances that always result in the exact same answer. Only in the situation where your of number is a 1 will you always have it equaling to a 0. So log base anything of 1 equals 0. So as long as it's of 1, it doesn't matter what the base is, it will always equal 0. If you have a base and an of, such as log base b of b, it will also equal 1. So whenever your base and your of are the exact same number, your answer will be equal to 1. Here's a quick example. Log base 2 of 2 is equal to 1. Log base 3 of 3 is also equal to 1. Using calculators for logs. If you don't see a little tiny number for the base, that is always assumed to be a base 10. It's kind of what we call the most basic log, or a common log. And though I don't write it, that little base number down there is a 10. Because this is the standard log, our common log, it's the log that you will be using in your calculator. You just simply in your calculator type in log of 4, and then it will give you the approximate decimal, 0.602. And this is rounded. Make sure when you're typing in fractions next to a log that in your calculator you're typing it with parentheses. This comes out to be negative 0.176, and also this is rounded. Now, what if you are trying to calculate a log that has a different base than 10, such as this example here with a log base 6? The way we do this is we use a method called the changing of base, change of base. You can rewrite any log with any base in the form of log with the of number divided by log of the base number. It's easy to remember where to put which number on top or bottom by remembering that the base, which is down low, goes on the bottom low, and the A, which is higher up than the B, goes up onto the top of our division problem. Once you have that written, you can easily type that into your calculator and come up with an answer. So log base 6 of 15 can be rewritten as log of 15 divided by log of 6. And we can type that into our calculator and come up with an answer. I got 1.51 approximately. So let's return to that original problem that we thought we couldn't do, that 2 to the x power equals 10. What we thought was impossible now is possible. First, we rewrite this as a log. Log, what's the base? It's a 2 of 10, and it equals the x. So I will find the x when I work out what log base 2 of 10 is. I'm going to use change of base, so I can type it into my calculator. Log 10 divided by log 2, and that, typed in my calculator, will give me my real answer for x. So my x is equal to approximately 3.322. There's that decimal that I was looking for in the very beginning. Okay, that covers your intro into logs, how to write them, how to use them, how to use change of base so we can put them into calculators. If you have questions, make sure you get them down to your notes and share them when you come into class. And don't forget to answer the questions after the video and hit the submit button.